3. Atlas, the mysterious interstellar visitor. Something strange is happening in our solar system right now. A visitor from another star system is plunging toward the sun, and it's behaving in ways that have astronomers scrambling to explain. Water erupting at impossible distances. A chemical signature that defies everything we know about comets. And in just days, it will face its ultimate test. This is the story of 3 Atlas, and what makes it so unprecedented. An unexpected arrival. Back in July 2025, telescope arrays picked up something unusual. A dim object streaking through space at velocities that shouldn't exist for anything orbiting our sun. Mathematical analysis confirmed what seemed impossible. This wasn't from here. Its trajectory proved it came from beyond our solar system, making it only the third confirmed interstellar object ever recorded, following the enigmatic Oumuamua in 2017 and Comet Borisov in 2019. By early October, as it crossed the orbital zone where Mars circles the Sun, orbital spacecraft managed to capture imagery of the approaching visitor. What they saw immediately raised questions. A brilliant, concentrated cloud of material surrounded the nucleus, yet no characteristic tail had formed. This was the first clue that 3 Atlas wasn't following the rulebook. Then came the truly bizarre measurements. Multiple observatories, including space-based infrared telescopes, detected something that shouldn't be possible. Water vapor streaming off the comet at roughly 40 kilograms every second, all while it was still nearly 3 times Earth's distance from the Sun. To put that in perspective, typical comets remain frozen and dormant at such distances. Water ice simply doesn't vaporize that far out. Yet here was undeniable evidence of intense outgassing where there should be silence. But the real shocker was the chemistry. When scientists analyzed the spectral signature of the gases surrounding 3 Atlas, they found an inverted ratio that broke fundamental assumptions about cometary composition. While normal comets are dominated by water ice with traces of carbon dioxide, this object was the opposite. Carbon dioxide appeared to be the main volatile, with water playing a secondary role. Additional measurements revealed dust particles with unusual light-scattering properties, suggesting grain structures or mineral compositions distinctly different from anything in our local cosmic neighborhood. Archive footage from satellite surveys even showed the comet was already active at 6 times Earth's distance from the Sun, an almost unheard-of phenomenon that hints at extraordinary volatility. Every data point confirmed the same conclusion. 3 Atlas formed somewhere completely different, under alien conditions we're only beginning to understand. Why this changes everything. The implications shake the foundations of planetary science. Under normal physics, water ice remains stable beyond 3 astronomical units from any star. Comets born in our solar system obey this law, staying inert until solar heating reaches critical thresholds. 3 Atlas shatters this pattern entirely. The leading hypothesis involves hypervolatile compounds, substances like carbon dioxide or carbon monoxide that can vaporize at extraordinarily low temperatures. Scientists theorize these materials lie beneath the surface, and even minimal solar radiation at extreme distances triggered sublimation. As these super-volatile ices turned to gas, internal pressure built up until the outer crust fractured, creating vents that released both the volatiles and trapped water far earlier than should be possible. An alternative explanation suggests the nucleus itself has an unusual internal architecture, perhaps highly porous or riddled with fractures from its violent ejection from its home system. Such a structure could allow sunlight to penetrate deep into the interior, warming subsurface ices that would normally remain frozen. The chemical profile offers a window into another star's planetary system. A carbon dioxide-rich composition strongly suggests formation in the frigid outer reaches of a protoplanetary disk around a distant sun, likely in regions far colder than where our own comets originated. This alien chemistry, combined with the unusual polarization signature of its dust, provides forensic evidence of its birthplace. Chemical fingerprints from a stellar environment we may never directly observe. While some researchers have raised provocative questions about whether such anomalies could indicate artificial objects, the current evidence for 3I Atlas points firmly toward natural origins, an exotic, volatile, rich body sculpted by conditions around another star. Together with its predecessors, 3I Atlas represents the third critical data point in an emerging field, the study of interstellar nomads. These cosmic wanderers serve as physical samples from distant stellar systems, offering direct evidence of how planet formation unfolds across the galaxy under varying conditions. The critical moment approaches. Everything has been building to what happens next. On October 29th, 2025, just days from now, 3I Atlas will reach Perihelion, its closest approach to our Sun at roughly half of Earth's orbital distance. At this point, solar radiation will intensify by orders of magnitude. What happens during this thermal gauntlet will determine the comet's fate. Scientists have outlined 3 possible scenarios, each with profound implications. Scenario 1. Explosive outburst. Maximum solar heating could trigger a catastrophic release of volatiles, causing the comet to brighten dramatically and finally develop the spectacular tail it has so far refused to grow. This would provide unprecedented data on how interstellar materials react to our Sun's energy. Scenario 2. Disintegration. Many volatile-rich comets don't survive perihelion. Thermal stress and rotational forces could tear 3I Atlas apart, exposing its interior composition in ways that would reveal secrets about its internal structure and the conditions where it formed billions of years ago. Scenario 3. Resilient passage. Though considered less probable, the comet might endure the encounter largely intact, maintaining structural integrity as it swings back toward interstellar space. This would suggest remarkable cohesion and could indicate a different internal composition than suspected. The weeks following perihelion will be crucial. Multiple spacecraft, positioned at different vantage points around the solar system, will monitor the comet's evolution. One probe, observing from beyond the Sun's position, is uniquely situated to track changes as 3I Atlas emerges from its closest approach, though will be operating on limited communications bandwidth during this period. Initial results are anticipated by early 2026. Meanwhile, Earth's most powerful telescopes, both orbital and ground-based, will capture real-time spectral data, tracking minute-by-minute changes in the comet's composition and activity level. If 3I Atlas survives, it will become visible again from Earth in early December 2025, passing at a safe distance of approximately 270 million kilometers. By comparing its chemical signature before and after the solar encounter, scientists can observe how our Sun alters material from another star system, an experiment impossible to replicate in any laboratory. Beyond one visitor, the significance extends far beyond understanding a single object. 3I Atlas is helping researchers model the exchange of material between stellar systems, demonstrating how debris from distant stars can traverse the vast darkness of interstellar space and enter our solar neighborhood. These insights illuminate the broader processes of planetary system formation, evolution, and interaction across cosmic timescales. This encounter also represents a proving ground for detection capabilities. Each interstellar visitor improves our ability to identify, track, and study these objects during their brief passage through our system. The data gathered informs estimates of how frequently such visitors arrive, their typical compositions, and their behavioral patterns when exposed to solar radiation. With advancing survey technology and improved early warning systems, future interstellar objects might be studied with even greater precision. Some researchers are already proposing dedicated flyby missions that could intercept such visitors, collecting direct samples or close-up imagery that would revolutionize our understanding of material from other star systems. What comes next? 3I Atlas represents something unprecedented in modern astronomy, a messenger from another stellar system displaying chemistry and behavior unlike anything we've previously encountered. Its unique volatility and inverted composition provide direct physical evidence of alien planetary conditions. What unfolds at Perihelion in the coming days could fundamentally reshape our approach to studying interstellar visitors and force us to reconsider assumptions about cometary science that have stood for decades. The universe has sent us a sample. Now we wait to see if it survives the fire.